All right, we're back. The last 15 minutes of our lecture here. We're talking about the coefficient of elasticity of demand. And, or, if you want to do this, if you can do, this is called Etta. It's not Etta James, she was a singer. That's called Etta. It's a Greek letter. If you can find it on your special characters, fine. If not, just use a capital N. N, not end. Where Q is the number of units demanded, which is basically going to be equal to how much they sell. And P is the price per unit. So we're looking at the relationship between Q and P. Now, these are the rules for demand elasticity. If N, I'm going to use N, if N is greater than 1 from here, we say that the demand is elastic. That is, the percentage decrease in demand is greater than the percentage increase in price. So it's very volatile. So it's a product that maybe is not valued that much, or there are a lot of alternatives to that product out there, which may not be as good, but since your price is higher, they're going to buy that product. This is called volatile demand. Now suppose we get, and this is less than 1. This is not 0. Well, one of the most common mistakes here is to think this is a 0. This is less than 1. Now, hint, 0.54 is less than 1. Okay, so it's not 0. Here, demand is inelastic. What does that mean? The percentage decrease in demand is less than, I should have put, let me put that down here, is less than the percentage increase in price. Arrow up means increase, so this means increase. Here we're increasing the price. We'll worry about what happens. And if n equals 1, we call that unitary demand, which means the percent decrease in demand equals the percent increase in price. So they follow each other. So this is the elasticity of demand. Now, what does the elasticity of demand mean? Well, it is not a slope, as we'll see. Elasticity is the rate at which demand is changing, but because of this, it measures the consumer's degree of responsiveness to a price change. So what this actually measures, the consumer's, let me write that here, consumer's degree of responsiveness to a price increase. Notice it's not simply a rate. This is a rate multiplied by some factor of minus P over Q. So here's your chart here. This will be on your charts for you when you take your exam. Although once we do a lot of problems like this, you'll realize questions usually will say, find n, what does that mean, and interpret it. You have to know this whole chart. Let's say n equals 2. The answer would be demand is elastic, which means that the percentage decrease in our demand is greater than the percentage increase in our price. So, let's take a couple of problems. If you want, I'll give you some time to write that down, although you can get it off the video. So let's take a simple problem. If you see a strange hand, that's Greg. He is making sure that my board is pristine clean. Okay, so example 1. Find the elasticity of demand. Demand given the following function for P plus 5Q equals 100. All right? And you want to know, you want to find it when P is $40, when P is $50, and when P is $60. Obviously, you're going to have to find out the corresponding Q's here. All right. Now you should have this down. If not, you can. Nice thing about asynchronous, you can go over the videos over and over again if you can stand me. Okay. So let's first find. So we have to go and see R minus P over Q dQ dP. So I'm going to find dQ dP first, which means that I'm going to call this equation 1. I have to solve equation 1 for Q. So we have 5 plus, P plus 5Q equals 100. Let's bring P to the other side. 5Q equals 100 minus P. Divide everything by 5. That's 100 over 5 minus P over 5, or written, 5 goes into 20, 5 goes into 100. All right, well, let me see how I chose to write it here. Oh, I know. 20 minus 1/5 P. Showing that that's the coefficient in front of P. So now I have the value for Q. So since I'm going to need P and Q here, I will eventually find Q also. So why not take this step first to find Q? So Q is going to equal to 20 minus 1/5. And let's do part A, where P is 40. So it's going to be 1/5 times 40. That's going to be 20 minus 8. So when 2 is 4, this is going to be 12. Okay, so that's A. So we can find our Q's for the other one too. So let's say this is Q when P is 40. So B, I want to find Q when P is 50. That's going to be Q equals 20 minus 1/5 times 50. And that is going to come out to equal to 10. And for C, when P is 60, that is going to be 20 minus 1/5 times 60, or 20 minus 12, and this is 8. So I have now, I can put this on the side of the board. A, when P equals 40, Q equals B, when P equals 40, when P equals 50, and C when P equals 60, Q equals, so I have this right here. So when Q equals 8, when P equals 50, Q equals 10. And P equals 40, Q equals 12. So let's leave that on the side. So now I have P and Q. So what I want to find is dQ dP. So let's erase this. And I have Q equals 20 minus 1/5 P. So dQ dP is ddP 20 minus ddP 1/5 P.
4 minutes.
So dQ dP is simply equal to 0 minus 1/5. So dQ dP is going to equal to minus 1/5. So we got dQ dP equals minus 1/5. So let's take the A1 that we want. And A says, okay, A says when P equals 40, we're going to have N equals minus P over Q, dQ dP, and we know here Q equals 12, so it's going to be minus 40 over 12 times minus 1/5, and the answer here comes out to be a positive. Let's see, I do have the somewhere here, hold on just for a minute. It's going to be 2/3, which is less than 1. Let's do B. P equals 50, Q equals 10. So N equals minus 50 over 10. dQ dP does not change. Minus 1/5. And when I do that, Q equals 50, I get that this is equal to 1. Now C, P equals 60. I believe Q equals 8. So N equals minus 60 over 8 minus 1/5. And that's another positive, but that is 3/2. And that's greater than 1. So what do we have here? This is less than 1. This is inelastic. Right? Go to our rules. Go back to our rule page. Okay? When N, wherever that is, when N is greater than 1, when N is less than 1, it is inelastic. This is 1, so this is unitary demand. This is greater than 1, this is very volatile, this is elastic. Okay, and I ask you, what does this mean? As I increase the percentage decrease in demand is going to be less than the percentage increase in price. This they're equal. Here the percentage decrease in demand. Percentage decrease in demand is going to be greater than the percentage increase in price. This is very volatile. This could be your cancer drug. This could be your highly competitive, and this could be in pretty much a flat industry. Okay, so this is the end of our now don't forget there is a quiz that I gave you. I will send that to you, and I will give you the due date based on 11.1, 11.2. Please call me on Google Hangout with your questions. You can talk to me. I have a whiteboard. We can go over things. It's a beautiful way of interacting. Better than email if you have to answer questions. I will see you next class. Take care of yourself and stay well.